So this video is a recording for the 2008 answer key for the chemistry section. So number 11 is asking about corrosion and combustion. So in those reactions, we have a metal, usually like iron, which reacts with oxygen and water. Okay, and those react to form iron oxide and water vapor. Okay. And when we burn something, we usually take our energy source, our fuel, carbon-based energy source, methane here in this occasion, and oxygen. So our combustion reaction produces carbon dioxide, water vapor, and light and heat energy. Okay, so that's also an exothermic reaction. So in both of those reactions, oxygen is a reactant. Okay, and water is actually a product according to these equations, so maybe not the best question. Okay, I would go with oxygen though. Okay, pick oxygen and reactant would be what they were looking for, not so much the water. Number 12 is talking about whether elements 3 and 4 are good or bad at conducting electricity. Okay, so in this case, we're trying to probably figure out which ones are metals. Okay, so one is a good conductor, one is a good insulator, or backwards. Okay, so let's take a look. So our melting and boiling points, that's going to tell us whether our material is either a solid, a liquid, or a gas at room temperature. So if the melting point is really high like this, that means it's going to be a metal at room temperature, right? It has to be heated up to 962 Celsius before it melts into a liquid. Okay, so that's going to be a solid. Lustrous silver, that means shiny, good at conducting electricity and heat, and malleable. Okay, so that one is going to be a metal, going to be a conductor, but they're not asking us about 2 or 1. Okay, but let's go over them anyways. If your melting point is at minus 218 and your boiling point is at minus 183, that's for sure going to be a gas at room temperature, right? And until it's like minus 182, it will be a gas. Okay, then it will melt, or then it will, what's that called? Condense. Okay, then it'll condense into a liquid. So it's colorless, it's a good insulator, probably like oxygen, something like that, not malleable. Okay, but they're asking us about 3 and 4, so again, let's have a look. Melting point, 115. So until 115 degrees Celsius, it's a solid. Until 1000 degrees Celsius, it's a solid. Okay, so these are both solids. Yellow, okay, great. Lustrous yellow, so shiny. More likely to be a metal here. We don't know if they conduct electricity or not. This one says not malleable. This one says very malleable. So I think the reason they're put number 1 and 2 on the chart is for us to match up that things that are malleable are good conductors, they're shiny, okay, and things that are not malleable are insulators. Okay, so let's see what we have here. Not malleable, it's probably a metalloid. Okay, it's yellow, and it's probably going to be an insulator. Okay, and this one here is very malleable, shiny, solid room temperature. That's probably going to be a good conductor. Okay, so 4, good conductor, yes. 3, good insulator. I'd probably pick that one. Okay, but it would be great if they gave us a little bit more information to answer that question. Number 3, what's the chemical name of a molecular substance? So it has to have 2 nonmetals. Okay, so that means we would use our molecular naming system where we have prefixes involved. And I'm not plugged in. Oh, maybe that doesn't matter. Hopefully the microphone is loud enough anyways. What is the chemical name? Okay, so this is where we'd use the prefixes. When you have 4, it would be tetra. And we always change the last little bit to "ide." So we have carbon tetrachloride, this one. Okay, chlorine no, because they don't have the "ide" at the end. Okay, this is what you'd call it if it was ionic. This example is showing a periodic table, okay, very similar to the one that they put in, or identical to the one they put in the 2010 PAT. Okay, so what is true about helium, neon, and argon? Okay, they have the same number of protons? No. Helium has 2, neon has 10, argon has 10. They have the same number of neutrons? No. 4 minus 2 is 2. 20 minus 10 is 10. 40 minus 18 is 22. Okay, so they have different neutrons. They're solids at 25 degrees Celsius? No, they're all gases, noble gases. Okay, are they going to react with other substances in a similar way? Yes. In fact, they're less likely to react because they're noble gases, and they have a full octet of 8 electrons. Okay. 15 is saying, okay, C6H12O6, which is basically sugar. Okay, what does C stand for? C is for carbon, yeah. H is for hydrogen. O is for oxygen. Okay, and then the number of atoms is 6 plus 12 plus 6, 24. So this bottom one, D. Which of the following is a chemical change? So the opposite of a chemical change is a physical change. In chemical changes, you get something new. Okay, usually there's fire or gas being produced, or heat or light, and you can't put it back the way it was. Okay, so liquid nitrogen evaporates. It can condense, it can turn back into liquid nitrogen. Okay, nothing new is being produced there. And whenever you see boiling, evaporation, melting, that's your clue right there that it's a physical change. Candle burning, fire takes the wax, and combustion reaction produces the ash, the carbon dioxide, the water vapor, and heat and light. So that one would be your chemical change. In 17, okay, 2 of these makes 1 of those. Okay, so when you take 2 metals, you don't get an ionic compound, you just get a alloy, it's called. Okay, but we don't always learn that. 2 metals makes a molecular compound? No. A metal and a non-metal gets you ionic, but 2 non-metals don't make ionic. 2 non-metals makes a molecular compound? Yes. And we would name them with prefixes. Which of the following is a solution? Okay, so something that has been dissolved in a solute, a solute that's been dissolved in a solvent would be something like acid rain, so that would work. Okay, the gases are dissolved in there, and it makes acid rain. Table salt is just a solid by itself. Okay, that would be a compound because it's NaCl usually. Helium gas is an element, it's all by itself. And baking soda is usually sodium carbonate, which is usually a compound. Okay, it would be really nice if they gave you the chemical formula for those to help you figure it out, but acid rain is the correct answer. Okay, in question 19, they are adding some hydrochloric acid to 4 different metals. They all start with the same mass of the metal and the same concentration of the acid. So those would be our controlled variables. And then our manipulated variable would be what kind of metal you put in. And it doesn't say what kind, it just says metal 1, 2, 3, 4. Okay, so the temperature after, okay, we react our metals with the hydrochloric acid. We can see that it has gone up the most here with 42. So that would react the most. Okay, and the mass of metal after it reacts with hydrochloric acid, so whichever one gets dissolved the most is going to be the one who reacts the most. Okay, so that would be this 14 here, which makes sense. Okay, so 3. That's what I'd put there. Some models of different molecules. chemical formula for the unknown molecule here. So they're having you look at the diagrams to try to figure out what this molecule looks like. Okay, I'm thinking that because there's no dark circles here that represent the phosphorus, there's probably no phosphorus in there. So let's take off A and B. Okay, we cross those out when we're doing our questions. Okay, then it looks like if that was oxygen, was the gray ones, the oxygen's probably a gray one, and carbon is probably the white one. Okay, so we have 2 carbons here. So I'm going to go with C, but let's double check. Okay, hydrogen, it's telling us, are the dark gray ones. We have 1, 2 hydrogens here, 1, 2 hydrogens here, 1, 2, 3, 4, 5, 6. 6 hydrogens there. 1, 2, 3, 4, 5, 6. So we have 1 oxygen, 6 hydrogens, 2 carbons. Okay, so let's go with C. Okay, and this would be close, right? But we usually put carbon first when we're putting chemical formula, and also it's missing a carbon. Okay, this one is has to do with conservation of mass. So whatever we have in terms of mass on the left-hand side of the equation, we should have on the right-hand side of the equation. So it's saying we're burning of magnesium. Heat's generated. Intense white light is emitted. And a mass of 130.8 grams of white magnesium oxide ash is produced. So how much oxygen reacted? Okay, I think I still have a combustion reaction sitting here. Okay, so in this case, methane was what we're being burned. Okay, and here it's magnesium. So instead we'd have magnesium plus oxygen makes magnesium oxide, carbon dioxide, or water vapor, or no, not carbon dioxide because we had no carbon in the first place. Okay, but what you need to do is you just take this number, subtract it by this number, and that tells you how much oxygen you have left. Okay, so 130.8 minus 70.2 is the math. 60.8 minus 2, 6. 60.6. Okay, so you'd write that on your numerical response. I think that's it for the chemistry section.